Hello all, welcome to Code Hub, and today let us solve the Lead Code's daily challenge. And the problem is, where will the ball fall? And this is the problem for the November 1, 2022 Lead Code daily challenge. And the problem is, you have a 2D grid of size m cross n representing a box, and you have n balls, that is a grid of dimensions m cross n, and there are n balls. The box is open at the top and bottom sides. Each cell in the box has a diagonal board spanning two corners of the cell that can redirect a ball to the right or to the left. What does that mean? A board that redirects the ball to the right spans the top left corner to the bottom right corner and is represented in the grid as grid as 1. That is, if my grid of ij is a 1, then what does that mean is, move the ball from top top left corner to bottom right corner, like that it goes. What like which means, you can see the first zero column is 1, so the ball falls at this position. It is going to this position because from top left it is going to bottom right. Similarly, if a board that redirects the ball to the left spans to the top right corner to the bottom left corner and is represented as -1. That is, if my grid of ij is -1, then move the ball from top right corner to bottom left corner. As you can see here, the I will copy paste this matrix so that it will be more easier. So this is the matrix, and if this you consider it as a grid, and you can see the first dimension, the first cell is a 1, so this ball makes it to move to its top left to bottom right, that is this position. And similarly, you can see that this cell is a -1 and this cell is a -1, then you have to move from top right corner to bottom left, which is this cell. So what does that mean is, if you are standing at this position I comma j, if my grid of ij is a 1, then I have to move to I plus 1 j plus 1 cell. And if my grid of ij is a -1, then what I have to do is I have to move my set to I minus 1, sorry, I plus 1, my next row, but column is decremented, I plus 1 and j minus 1. So this is what we are going to do. So what does the problem states? We drop one ball at the top of each column of the box. That is, this is considered as the box and this is the matrix. So we have a column, we have balls of column size, that is n balls. So we are going to drop, for each column we are going to drop one ball. A ball gets stuck if it's a v-shaped pattern between two boards, or if a board redirects the ball into either wall of the box, either if the ball touches the wall of the box, that is either this black line, you can see this black line, if the ball touches the boundaries, that is, what are the cases? If ball touches the boundary or v-shaped pattern, then ball stucks. So that is what they're meaning. But how can we find the v-shaped pattern? V-shaped pattern can be found by, as you can see that this is a v-shape. Why this is a v-shape? The third cell and the fourth cell is a 1 and -1 respectively. The third cell is a 1 and -1, that is, and you can see this cell which is 0 2 and 0 3, the cell at 0 2 and 0 3, there is a 1 and a -1, that is also v-shaped. So what does that v shape is? If there is a 1 and if its adjacent right cell is having a -1, then there will be a v shape. So this is the condition to be a v-shaped pattern. So if this is occurring, then we cannot move the ball further, and the ball will not fall down. So return an array of answer of size n. Answer of I is the column that the ball falls out of the ball out at the bottom after dropping the ball from the ith column at the top, or -1 if the ball gets stuck in the box. So what do they mean is, if ball stacks, my answer of I is a -1 is equal to -1, else my answer of I is equal to column number where the ball falls. So we have to determine this is our problem basically. So hope I made you to understand what are the cases and what is the problem is required. As you can see, this is the matrix. This is the matrix given. If you can see, if I drop a ball from this zeroth column, I move in this direction. This here's a 1, here's a 1, then my -1, and I'm moving and finishing at this column 1. So the answer is 1, you can see. And you can see these four balls cannot reach the bottom, so it is a -1. All the cells are a -1. And here the why this is a -1, our answer is -1, because the grid of 0 comma 0 indicates -1. That specifically means we have to move in this direction, I plus 1 and j minus 1. And you can see that j minus 1 is a boundary case. We are having a only 0 comma 0, we don't have a -1 column. So we have reached the boundary, so we are returning a -1. We are now, the ball gets stuck with the boundary case. And similarly, you can also trace out this balls, and you can also see, you will get the output for 0 1 2 3 4 and -1. So how can we solve this problem? So anyways, we have to make all the balls to fall from each of the every column. So what we can do is, I think I have covered all the cases here itself. We just want to code. So what we can do is, we can run a for loop for each and every column, and we can have function which is going to check whether that function can reach the bottom. We can reach the bottom cell, bottom cell in the sense bottom row. If I can reach a bottom row, then the ball is always falling down of that board, and you can definitely return the column number. But if I get stuck, that is, if I have a boundary case, or if I have a v-shaped pattern, then the ball stucks, then I can return false. So what I do is, I can first have a answer. I have first we can declare an answer or vector of size n. This is going to be the columns, n balls, right? So the m is nothing but my grid dot size, and int n is equal to grid of 0 dot size. So I have rows and columns. So I have an answer vector of size n. Now what I have to do is, I have to run for each and every column. I have to drop the cells. So for int I equal to 0, I less than n, I plus plus. What I do is, I will get the x and y. X is nothing but my first row, so that is nothing but 0th row, and my y is nothing but the column number, which is I. So what I do is, I will call the function uh, falling column falling column falling column. This falling column function is going to give me the column number that the ball is falling at the bottom, else return me a -1 if it is not able to do. So I will pass the grid, I will pass x, y, and the m and n. So now I will define the function uh, falling column. This function is what I'm going to do is, I'm going to return an int variable, and the parameters are vector of int ampersand grid, and int x, int y, the rows and the columns, and definitely I need the columns. Then what I will do is, first I will check. What I have to do is, I have to make this row number equal to m. That means I have made the ball to reach the bottom cell. So to to make the ball reach the bottom of the board, we have to say x is equal to m. So what I specifically do is I will run a loop while my x and y are in the range, or in the range in the sense while my x and y, if my x, y, m, n, this function is going to say whether this is in my range. That is, if bool is valid, and I definitely need x and y, then my rows and columns. This is going to say me if my x is greater than or equal to 0 and x is less than m, and my y is greater than or equal to 0 and my y is less than my columns. So this is going to return me true. If it is true, then I can specifically move in the direction that is specified. That is, if my grid is grid ij is a -1, then I have to move in I plus 1, j plus 1, and I have to if my grade of ij is -1, then I have to move I plus 1 and j minus 1. So what I will do is, if my grid of ij in the sense xy, so if my grid of xy is, obviously you can see that I plus 1 is a common factor. So what I can do is, whenever I can I'm going to run this while condition, I can just increment my row number. So whenever grid of xy is xy is 1, then I have to increment my column number y plus plus, else I have to decrement my column number y minus minus. So hope this is clear. But one thing what I have to check is, I have to check for its boundary cases. Boundary cases in the sense, if I have reached the V-shaped pattern, then there will be then the ball will stuck in the board. So to check whether the ball is stuck in the board, we have to see whether the V-shaped pattern lies or not. V-shaped pattern check. How can we check this V-shaped pattern is, if my grid of ixy, or else I will take this value, take in this value curval is null, or else I will say it as direction. Int direction is equal to grid of xy. If my direction is 1, then the right cell, then the adjacent right cell should be a -1. If my direction is 1, then my adjacent right cell should be a -1. If it is so, if my direction is a 1, then what I have to do is, I want to check for one case, either my y plus 1 is greater than or equal to the column number, or if it is in a range, then my grid of x y plus 1 is equal to -1. If this is the case, then I can just return a -1. So here the ball will get stuck. Now there lies in another case. If my direction is equal to -1, then my immediate left adjacent cell should be a 1. If I am at this position, my left adjacent cell should be a 1. Then I can form a V-shaped pattern. So either my y minus 1 should be less than 0, I have reached the boundary, or else my grid of x y minus 1 is equal to 1. That we can say it as like this itself. If it is so, then I have to return -1. So this is the boundary cases where the ball will get stuck. Ball stucks. So these are the cases where the ball gets stuck, and if this is not getting stuck, obviously I'm going to reach my boundary case. I'm going to reach the next rows, that particular direction cell. So I will be incrementing my row, and if my grid of xy is 1, I will move my column, and else I will move my row. So if this is the case, if nothing can happen, I can just return my y. Why so? Because I have to return the column number. If everything is true, definitely my ball is reaching the last row. If I can reach the last row, definitely I can say it as a, I can say that to be a answer. My column number is my answer. So now let us try to run our code. Oh, before running, at the end of the day, I'm going to return my answer. Now let us try to run the code. Okay, it gets some error. Let us see. Okay, I think I have to check here another case. What is that case is, if my x has reached my last row, then I'm returning a -1, else returning the column number, else return -1. That is, I am double checking whether this x has reached the last row. If it is so, then I can just return the column number, else returning -1. Now at least we can check what is happening. Okay, even now I'm not getting this one. Why is it so? Let us try to figure it out. Mm, obviously I'm incrementing my row. If my grid of xy is a 1, that is, if my direction is 1, then it is y should be incremented, else my column should be decremented. If my direction is 1, then my column should be incremented, else my column should be decremented. If my current value is a 1, if my current column is a 1, and if my y plus 1 is greater than the column number, or if my grid of x y plus 1 is a -1, then return -1. It should be correct, right? I think even this -1 is equal, is becoming as a true. I think if this is 1, grid of x my y minus 1 is 1, then only I can return false. I think even this case is wrong. But what is the issue? So here the grid of x y minus 1 is 1. Okay, now let us check here also, change here also. If my direction is 1, then I will increment my column, or I will decrement my column. Now let us try to run the code. It's a blunder mistake, but hope now it works correctly. I think now I can reduce this as well. We can just return the column number always. Let us try to run, or else we can include that statement. Yeah, it gets accepted. So now let us submit our code. So what will be the time complexity for the solution? Superb, it gets accepted. So now let us try to do a complexity analysis. So the time complexity here is nothing but there will be an order of n cross for each rows. So if I can make the all the balls drop to the column, obviously we are going to run a m cross n for this loop. And finally we are using a space also of size column. So the time complexity here will be order of m cross n, and the space complexity will be order of n. So hope you like the solution, and it is a quite simple problem if we get the clear understanding and clear analysis of those edge cases. So let us see in tomorrow's LeetCode daily challenge. Until then, bye.